Hi, I'm Norm Abram. Welcome to the new Yankee Workshop. Today we revisit a two-part program we did here several years ago. It involves so many steps that we decided to divide it into two programs. And even at that, it was a challenge to fit everything in. The project was to build a simple backyard greenhouse, suitable for raising and displaying plants that require some protection from the cold. We would need a level site, big enough for a small 6-foot by 8-foot greenhouse that got 6 hours or more of sunlight in the spring and fall, and near enough to a water and electric supply for easy tending. We probably wouldn't worry about heating it in the coldest days of winter, and that was before heating oil and gas became so prohibitively expensive. All right, and finally the other gable end. Instead of using real glass for glazing, we would substitute a clear double-wall polycarbonate that many professional growers use today to save energy. Such material and related accessories would be available on the internet, or in our case, from a greenhouse supply company. Instead of using aluminum framing, which is used for most commercial houses, we would make our frame out of wood and machine it with our woodworking tools. Instead of a concrete floor for a foundation, we would use a system of 8x8 pressure-treated sills laying on a bed of crushed gravel, which had the advantage of making the greenhouse portable if it ever needed to be moved. Now, once these panels are set in place, it's going to give us quite a surface that the wind can catch and want to lift the building. So I'm going to secure it with these long pieces of number 4 rebar. One in each corner should do the job. Here's how we got started. Greenhouse Part 1. That's next, right here in the new Yankee Workshop. Now, our greenhouse is going to be about 6 feet wide, 8 feet long, and 9 feet to the peak of the roof. And if you'd like to build one, a measured drawing will be available with the materials list, and you'll hear more about that before the program ends. The foundation for the greenhouse is going to be made up of these 6x6 pressure-treated pine timbers, much like I used on the storage shed. I'm going to build a perimeter frame with half-lap joints at the corners. So I've laid out the material that has to be removed to make the half-lap. I'll first make cuts with the circular saw, and then I'll finish them off with the handsaw. But before we use any power tools, let's take a moment to talk about shop safety. Be sure to read, understand, and follow all the safety rules that come with your power tools. Knowing how to use your power tools properly will greatly reduce the risk of personal injury. And remember this, there is no more important safety rule than to wear these safety glasses. And this will finish it off. I've set aside the timbers for the foundation, and now I'm at the other end of the greenhouse, right up at the peak of the roof. I'm using redwood for the frame, and these 2x4s, which will be the rafters, also need a half-lap joint. Now, to make the half-lap, I've set up a stacked dado head cutter in my radial arm saw, and I've installed this stop block to give me the shoulder, or the length, of the half-lap. Now, here's a tip. If you set the stop at an angle, you reduce the possibility of sawdust building up against the stop that would give you a false cut on your shoulder. The next operation on these rafters is to make a groove to hold the glazing. Now, here's a sample of the glazing. It's a polycarbonate, 2 thicknesses with webs between, and it's quite clear. You can see right through it. And it's very strong. It adds some insulation value, and I'm just going to set it into a groove in the side of the rafter. On the gable ends, I'll need grooves on the inside. For all the other frames, grooves on both sides of the rafter. To make the groove, I'm using my 5/16 stacked dado head setup for a depth of 3/8 of an inch. Let's look at our sample rafters again. Because of the half lap, I'm going to have to make a groove across the grain so that the glazing can make it all the way to the peak. I'll make that cross cut using my miter gauge. The next step is to make a groove along the bottom of all the rafters. On the gable end rafters, it will receive the glazing and a collar tie. On the intermediate frames, just for the collar tie. The next step is to make a notch at the bottom of each rafter, and this will fit over a ledger board that ties all the frames together. So I've established a fence at my bandsaw, and the first thing I want to do is make the rip cut. To complete each notch, I'm using my miter gauge set at a 45-degree angle. The studs on which the rafters will sit and the sill plates will be 2x3s. So I'm taking 2x6s, ripping them in half, cleaning up the sawn edge at the joiner. The next operation is to cut the top of each stud to this shape. The angled portion picks up the bottom of the rafter. The flat portion will pick up a ledger, which is going to tie everything together. I've laid out the cut. The first thing I do is make the square cut at the radial arm. I'll complete the cut at the bandsaw. My miter gauge is set at the same angle that I used on the rafters, 45 degrees. The next operation is to make 4 studs with a very simple notch that will pick up a redwood ledger board later. I'll make the notch using the radial arm for the crosscut, the bandsaw for the rip. Well, now I'm back at the table saw making grooves in all the studs, just as I did with the rafters. Let me show you what that's all about. There are 3 different layouts for the grooves, depending on what the stud is being used for. There are 6 intermediate studs. There's a groove along the edge for bracing, and a groove on each side for the glazing. At the corners, there are double studs. This is the gable stud, and it has a groove for the glazing and the braces. The doubler just has a groove for the glazing. Let's finish them up. Here I'm dry fitting a pair of the gable end rafters together, and I want to show you the blocks we're going to make next. Each will add structural integrity to the piece. A little block at the top with tenons that fit into the bottom of the rafters. A collar tie, which will keep the rafters from spreading apart, again with a tenon, and grooves for the glazing. And down at the bottom of each rafter, there's this knee brace, which has tenons that fit into the groove of the rafter and into the groove of the stud. I'm set up to make the knee braces first. I've attached this auxiliary fence to my radial arm saw, just using a couple screws. I've tipped the blade or turned the saw to 25 degrees, and I'm ready to make the first cut. I've removed the auxiliary fence, turned the saw to 45 degrees. Now I place the cut edge against the fence and make the second cut. While the radial arm is still turned to 45 degrees, I'll cut the 5 collar ties and the 5 top blocks to size. Now I'm ready to start forming the tenons. So I've set up my stacked dado head cutter for maximum width, installed a sacrificial fence, and I'm using my miter gauge to guide each piece through. Now I've turned my miter gauge to 45 degrees on the other side of 0, and I'll make a pass on the other face. Now with the miter gauge set to 90 degrees, I can make the second pass on the ridge block. Now the knee braces. With the dado head raised, I'm going to make one pass on one side of each tenon. The result will be an offset tenon, which is what I want. Now with the dado head reduced to the size I need for the glazing, I'll make the appropriate grooves in all the blocks or collar ties. Here I'm drilling some holes in the collar ties of the gable ends, and they will be useful to relieve some condensation problems that may happen in the panels. Here's the glazing for our greenhouse. It comes in 4-foot by 12-foot or 16-foot sheets. We picked it up at our greenhouse supply company, and it comes with a film on each side to protect it while we're working with it. It's double wall, which gives it insulating value, and the side that has the blue film on it has to face out because it has a UV protector, which will extend the life of the polycarbonate, yet it lets all the light through. Fairly easy to cut using a fine-tooth blade. I'm using a plywood blade in my circular saw. The first piece I want to cut is this triangle, which is for the top of the gable end. Now I'm ready to glaze one of the gable ends. And the first thing I have to do is seal the top edges of the glazing. The manufacturer supplies a self-sticking aluminum tape for that purpose. The tape that I use along the bottom edge is a fabric tape. It'll keep bugs and debris out, yet it will let any condensation that builds up in the panel escape. Now I'm ready to assemble one of the gable ends. And I'm going to use this moisture-cured glue, which calls for wetting one of the surfaces and applying the glue to the other. To secure the joint while the glue dries, I'm just using a few 1 1/4 inch brads. Now I'm going to apply glue to the tenon of the ridge block, and we'll set that in place. Now a clamp to just pull it tightly into place, and I'll pin it with a couple more brads. Now make sure the blue film is facing out and slip the glazing into place. All right, that's partway in. Now let's try to slip the collar tie in place. I think a clamp would be useful to help pull the collar tie into place. Now it's starting to go. Now this is the other gable end. And this time I used the collar tie to drive the glazing into place before I glued it. That way I made sure that it was set exactly where I wanted it. It seems to go a little bit easier. You learn something with every one of these that you do. Yeah, it's 5'10" 3/8. Notch to notch, that's just right. Now we can pin it. All right. Now while that gable end dries, the next step is to attach the knee braces to the individual studs. And for that, once again, the moisture-cured glue, applying it to one surface, which is dry, and just wetting the mating surface. The next step is to work on the sill plates for the gable end. I've laid out the location of each stud, and I want to make a notch so that the stud will sit into the sill plate. The best way to do that is with the radial arm and the stacked dado head cutter. With the same setup, I'm going to make notches in the sill plates for the side walls to receive the studs. This next piece of 2x4 becomes a purlin, and I've laid it out for some notches where it will intersect the midspan of the rafters. It'll help support the glass and stabilize the roof. With my saw blade tipped to 45 degrees, I'm going to rip the top edge of this 2x4. It'll become the top plate which fits into the notches on those rafters. And those pieces will need a groove for the glazing. A couple of holes in the sill plate at each glazing panel will relieve any condensation problems. Well, now we're finally ready for the first major assembly. And the first thing I want to do is attach the end studs of the gable wall to the truss assembly. So some more of that moisture-cured glue on the tenons, put it together and tack it with some brads. Now I'm just going to take a sample of my top ledger and make sure that that's going to fit in here okay before I tack it. That is good. I'm going to put a clamp on this, and perhaps it won't come apart when I put the glazing in. I've installed the vent tape along the bottom edge and the foil tape along the top edge, just as I did before. Now let's see if we can get it to fit in these slots. Now I got to get the other side set in the groove. Now this is one of the studs that'll form the door opening, and that gets glued in place and it slips over the glazing. And now I'm ready to pin this side. And now the sill plate. This is going to be a little tricky because I've got to slip it over the studs and into the glazing. Okay, that's pretty good. Now I'm going to secure these joints with some screws. Well, I think we'll let this set until the glue dries. Then I'll build the other gable end that has a window in it. Well, before I left last night, I was able to complete the other gable using the same techniques that I used on this one. Now I'm starting on the side walls. The sill plate for the side wall is the same as the gable in that it has a groove for the glass and weep holes to let any condensation out. There are shallow dados for the intermediate studs, which have the knee braces that we made earlier. The end stud has no knee brace, but it has a notch to receive the top plate. They're assembled with 2.5-inch screws. Now the end stud has to overhang the plate. The gable end will slip in underneath it. Now for the glazing, just slide it into the groove, being sure that the blue film faces out. Now a little bit more of our high-tech glue to secure the joint between the stud and the top plate. Okay, we'll just slip this onto the glazing. Now to keep it square, I think I'll just tack a batten on it. Well, before long, we're going to need the foundation for our greenhouse, so I'm getting started today by setting the timbers on a setting bed, just making sure that they're level. Now, each corner is joined together with 2 lag screws. I like to clamp the corner together, that way it stays in position as I do the drilling. I'm going to start with a 1.5-inch spade bit to make a counterbore to recess the head. Now I'm going to switch to a 3/8 auger bit to drill a pilot hole for the lag screw. Now there's one more hole in each corner. This time I'm using a 1/2-inch bit, and I want to go all the way through. Now once these panels are set in place, it's going to give us quite a surface that the wind can catch and want to lift the building. So I'm going to secure it with these long pieces of number 4 rebar. One in each corner should do the job. Let's get the rest of the panels and start the assembly. This is an important step. I'm snapping chalk lines to show me the inside of the sill plates. When I designed the greenhouse, I made it so the wall will overhang the foundation just enough to let the water drain out of those weep holes if there's any condensation in the glazing. All right, we'll set this gable first. Bring it to the line, and there's not much to secure this, just some 2.5-inch screws. Could you imagine how heavy these panels would be if they were double-wall glass? This acrylic makes them nice and light. Now this corner will just slip together, and we'll secure it to the sill with some more screws. Right, and finally the other gable end. That's good. Okay, we got a good start on our backyard greenhouse. Now next time we'll build the roof, make a window and a door, and we even have a way to make roof vents that'll allow the heat to escape from the greenhouse. Then we'll build some benches. That's next time right here on the New Yankee Workshop. order a home video or a measured drawing of the project you've just seen, please call 866-545-9708. Additional information is available at newyankee.com.